Hey, what's up guys? My name's Dustin and welcome to a new series, well, not a full series, but a little mini series on calibrating and getting your Folger Kossel 2020 working at its best. That's the whole idea of this. This series is going to take you along the way through the mechanical setup and the programming and the slicers, and also the auto bed leveling, calibrating all that nonsense to get this thing performing at its best, or at least the best that I can get it working at. This first video is just going to be talking about the actual mechanical side of the actual printer, just, what you did when you put it together, just making sure everything's set up how it should be. The next videos are going to be looking into the programming of it and things like that. But for right now, let's just see what we can do. Now, all in all, putting this printer together isn't that complicated, especially if you have experience putting stuff together. Of course, you know, I've done the printer, my Prusa before, so that was easy. And of course, I have a lot of experience putting things together. If you have a lot of experience with electronics or even Arduino, coding, things like that, it's going to make putting this kind of thing together really, really easy. And I will go more in depth in that in a review that I'm going to be doing on this printer in the future. I don't know exactly when that's going to be, but that will be coming. Like I said, putting this thing together isn't that complicated, but there are things you need to look for when putting it together that if they're not correct, the printer won't perform optimally or at all if you're not careful. So first things first, you need to finish building the printer, obviously. It's not going to work without you being pretty much done with it. The build guide that Folger offers is pretty good. They're very detailed in what you need to do to put everything together and the wiring diagrams and all that kind of stuff. So finish the printer. So the first thing you want to look at when you're building this printer is going to be these tower uprights and this top base up here. The main thing is you want the distance from the top of this upright to the top of the base to be the same all the way around. It doesn't matter all that much the exact number, more so that they're all the same. So in my case, I think mine is like 20 millimeters or so from the top up here, and I'll illustrate this on screen. But that doesn't necessarily mean it needs to be 20 millimeter. As long as they're all the same all the way around, that's where it matters. The next thing you want to look at is, once you've got that level all the way around, you want to level all of these end stops once you have the end stops on. That's one of the biggest things you're going to really want to do, is make sure all the end stops are the same distance from this top base. That way, theoretically, they're the exact same distance from the bottom base, which is going to give you better prints in the end. In my case, I didn't really have an easy way to measure the actual distance all the way around. So what I actually did was took a penny, just a regular penny, and put it up in there and just adjusted the actual end stop until the penny was squished up in between the end stop and the top of the base. And if you do that all the way around, you're going to know that the end stops are pretty close to being level all the way around. The next big thing you're going to want to make sure you do, and you got to be careful on this one, is these smooth rods that you had to make with the carbon fiber rods and these little tie rod ends. You need to make sure that when you go and cut these actual smooth rods, that they're all the same length. You got to make sure that they are as close as you possibly can to being the exact same length. And when you go and install these tie rods on the end, make sure that it equals out to being the same length. That is the biggest thing that's going to mess up your calibration if you don't have it right. They do supply you with an extra rod just in case you screw up, and that's totally fine. You can buy more of this rod if you absolutely need to, but they all need to be the exact same length. In my case, from the center to the center of the tie rods, it's 240 millimeters, give or take half a millimeter, which, you know, you're never going to be able to get it absolutely perfect unless you're using machinery. I was using hand tools, so there's just ever so slightly a small amount of mess up, but, you know, you're going to have to live with something like that. But the distance of the entire smooth rod, including the tie rod ends, is going to be 240 millimeter center to center of the actual screw holes or bolt holes. The smooth rod itself, when I cut the actual carbon fiber rod, it was, I believe, 190 millimeter. And if I'm wrong, I'll put a thing right here. But once you add the 25 millimeters each on the smooth rods, it's going to give you an extra 50, which is going to be 240 millimeter. But you're going to have to make 6 So make sure all 6 are the exact same length. Also, when you go to do those, make sure you use a lot of super glue when you're putting it all together, because you really want it to be strong and not become loose while you're printing, because that would be really devastating. Another big thing that I actually ran into was making sure the motors and end stops are actually in the right orientation. So if you're looking at the printer from the bottom like this, you need to have the X, Y, and Z motors lined up X, Y, Z. And of course, if you're looking at it from the top, it needs to be X, Y, and Z. Now, which axis is the actual X or the Y or the Z isn't really important. It doesn't matter that this one right here needs to be the X and that one needs to be the Y. As long as they're in the right order all the way around, that's what matters. So if you want to start off this one as your Z-axis or this one is your Z-axis, that's totally fine. As long as, in my case, it'd be X, Y, Z. That's the main thing. You want it to be, if you're looking at it from the bottom, you follow it clockwise, start at X, and the next one should be Y, and the next one should be Z. It doesn't matter which one starts off the sequence, as long as they're in that sequence clockwise from the bottom. Now, when I built this printer, I reversed the X and Y motors. I actually had them oriented backwards, so instead of being X, Y, Z from the bottom, it was Y, X, Z from the bottom. And so when I actually did that, it was actually printing the prints in mirrored. It was printing, things that were supposed to be on the left were on the right, and it was just completely mirrored, which when I made a couple bolts and nuts, they actually reverse threaded them, and that was kind of weird. I'm like, why is this a problem? Because the motors were actually reversed. So if you see something like that, if you're having problems with that, that's probably what it is. So just make sure you're oriented correctly. Other things that you need to look out for is just going to be simply, the belts. Make sure that they're tight. You don't want them to be extremely cranked down, but you want them to be tight enough to where they're kind of springy. Of course, these are pretty long stretches, so it's going to be pretty springy anyway. But you do want these to be fairly tight, so there's no skipping of any of the teeth or anything like that, which would throw off your prints, and that's not good. When you go to tighten up the timing belt, they do supply you with these little, they almost look like the clothespin springs. They're pretty much identical to those. They supply you with a bunch in this kit, and pretty much any 3D printer kit that's decent will give you some of those. And those are actually used for tightening these timing belts. I'll show you an illustration of how you put it on there. When you go and install the belt, you want to get it as tight as you can just as you're installing it, and then use those if they become loose or if they're not quite tight enough from the beginning. But like I said, you want it to be tight, but don't overbear it because you don't want to break the belts. That'd be bad too. Another thing you want to look out for, and I'm going to be talking about this more in another video, is going to be the actual bed sensor, the inductive sensor. You want that to be almost level with the tip of the nozzle. I'll go into that more when we get around to it in the programming and in the Arduino code. But basically, if you touch this all the way down, the tip is actually touching the bed. I'll zoom in on this, you'll be able to see it. You want the inductive sensor to be pretty damn close to the bed with the actual nozzle touching the bed. You don't want it to be past it, or you don't want it to be pretty much level with it, because then it might touch some of your prints as it's going down, and that's not going to be good. That's going to start messing up things. So you want it to be offset just a little bit, and there is part of the code which we'll be modifying that will adjust the offset that you have it set at. We'll go into that when we get into the programming aspect of it in another video. Pretty much the only thing, if you follow those directions, is going to be just make sure you put the thing together following the directions that they gave you. Make sure all the wiring is going to be correct. Make sure everything is how they said it would be. And you shouldn't have any problems. So for the mechanical side, there's not much really I need to talk about after this. If I come up with anything else, I'll mention it in the next video. But other than that, you're pretty much on your way to getting this thing set up correctly. So in the next video, I'm probably going to start introducing any last electronic things, and then going into the Arduino code for messing with things to get everything calibrated. And then from there, we're probably going to get into getting it working in Repetier host, and then looking at the slicers, and then any other thing that you really need to look into. Those will be future videos. They should be coming in the near future. But for now, this is going to hold you over for a little bit. Just, if you're doing this right now and you're seeing this video the day it came out, just stick with me. There'll be more videos to come. If you're seeing this in the future, this will probably be in a playlist. So just watch the playlist, and you'll be able to see all the videos that I've made about this printer. So yeah, anyway, so thank you all for watching. Feel free to subscribe if you want to stay up to date with videos about this printer or any other 3D printer or computers, technology, music. I'm going to be doing some guitar reviews in the future, so stay tuned for that. If you want to, you can follow me on Twitter. There'll be a link in the description. If you have any questions or concerns about my videos or anything, you can leave a comment on YouTube and I will usually be able to get back to you, barring your account is able to have comments sent to them or replies. Some people aren't allowed to, or some people's accounts won't let me do that, and I can't respond to your question. But if you have a Twitter, feel free to follow me on there. Message me, direct message me, or tweet at me, and I'll be able to get to you really, really quick because I get notified for everything that happens on Twitter. Whereas YouTube, I have to be on YouTube to get notified if there's a comment or something like that. So it's the easiest way to get in touch with me is going to be on Twitter. So link in the description. Also, a subscribe link will be in the description if you want to do that too. If you don't, totally cool. If you do, I appreciate it very much. So anyway, thanks again for watching. So until the next video, I'll see y'all later.